So today we are going to study rate monotonic scheduling.
It is a static scheduling. The priority does not change.
So the question given is process P1, P2, P3. Execution time is given as C. It's 1 millisecond, 1 millisecond, 2 milliseconds. And period is 3 milliseconds, 4 milliseconds, and 6 milliseconds. So period sometimes can be given as P also. So C means execution time, P means period. Here this period is taken as a priority. So the lowest period is taken as the highest priority. So P1 is having the highest priority. Then the next period is 4. So this will be having the second priority. And the last priority is 6 milliseconds. So this will be having the third priority. Now we are going to draw. Now what happens here is, first we are going to note the intervals. So here P1 executes for execution time of 1 milliseconds every 3 intervals. So 3 milliseconds. So if you take this as P1 lane, here it starts at 0, and here we are having a interval. So that is the first interval, that is 3 milliseconds. So before that we can calculate the hyper period. So hyper period is the LCM of 3, 4 and 6, which is taken as 12 milliseconds. So we are going to draw this timeline for 12, because after this 12 milliseconds there will be a cycle of repetition of the same thing again and again. So 12 milliseconds of drawing this is enough. Okay, so now I'm going to note down the intervals. So till 12 I'm going to draw the intervals in 3 threes. Okay, so the first 3 is the first interval. Now the second interval is the next 3. 4, 5, 6. So this is the second interval and it ends at 6. Next is the third interval, 7, 8, 9. That will go on for 9. The fourth interval should be at 12. 12 you are having the fourth interval. Similarly you are going to draw for P2 also. So P2, the first interval will come at 4 milliseconds, 4. Second interval at 4 plus 4, 8. Third interval will be at 12. Similarly for P3 it will come at 6. So the first one will be at 6 and the second one will be at 12. So now we are going to draw it. So initially P1 is having the highest priority and it executes for 1 millisecond. So P1, its execution completes in 1 millisecond. Next one is P2. So the next priority is P2. So P2 that executes in for a 1 millisecond. So its completion is by 1 millisecond. Next priority is P3. So P3 will execute for 2 milliseconds. So you start the first one and then next you wait. While waiting here you can see the first interval of P1 is over and it's waiting for the new instance has arrived. It's waiting for its next cycle execution. So what we have to check is the priority. Here P1 is having higher priority than P3. So you are going to hold this P3 and you are going to start this P1. So it will execute 1 millisecond in this interval. Okay, the next priority you are going to check. Here you can see that after P1, P2 is the next highest priority. So P2 will execute. Next you can see here for this cycle already P3 has started its execution but it hasn't completed. So only 1 millisecond is over. So the remaining 1 millisecond will get executed and P3 gets completed for this interval. Next again you are going to check here the second cycle of this the next cycle of this P1 is going to start. So here actually P2 has completed here its interval here. So you don't need to worry about P2. You can just go to P1 and also P1 is the highest priority. So you start with P1. Next priority is P2, but P2 is already completed for this interval. 1 millisecond is over. So no need to repeat P2. Then we can't repeat P2. So we are going to P3. So P3's next cycle has started here. So we can go to P2. But P3 hasn't completed. You have to hold it because suddenly now P2's next interval is started. So here you have to complete P2. And then when you come here, this P1 has also started. So P1 is higher priority than P3. So P1 has to complete its 1 milliseconds execution and then it has to go to the next one. So here for this interval P2 is already executed. So we will skip on P2 and then we'll go to P3. So P3 only 1 millisecond is over, but actually P3 is 2 milliseconds. So the remaining cycle of P3 will go here. So 2 milliseconds is completed here. And finally, so all the particular interval, every process has executed. So this stage is called as idle from 11 to 12. So if you want to write it as in a table format, you can write it also in a table form. So that have one time, then running task, then what's the reason for it to be running now. So at a time interval 0 to 1, you can see that P1 is executing because it is the highest priority. Next for 1 to 2, P2 is executing because it's the next highest priority. Next from 2 to 3, P3 because after these two it's having the next priority, so it's the lowest priority. Then 3 to 4, P1 will be executing since it's a new instance is going to start. New instance. Next from 4 to 5, We'll check P2 because it's a new instance. Next from 5 to 6, P3. This is the remaining. So remaining part already 1 millisecond is over. The remaining millisecond you're executing the remaining execution. Next 6 to 7, P1. This is the new instance. 7 to 8, P3. It's the lowest priority. That's right. Then 8 to 9, P2. New instance. 9 to 10, P1. New instance. 10 to 11, P3. It's the remaining execution. And 11 to 12, idle state. So whatever is here, I'm just noting with a particular reason, that's all. No task to execute. So this is RMS scheduling algorithm.